So I'm going to review significance tests from Chapter 9 before your quiz. So our first problem, we have that a company that makes cola drinks states that the mean caffeine content per one 12-ounce bottle is 40 milligrams. You work as a quality control manager and believe this to be false. During your test, you find that a random sample of 30 12-ounce bottles of cola has a mean caffeine content of 39.2 milligrams with a standard deviation of 7.5 milligrams. At alpha equals 0.02, does this indicate that you are correct and that the mean is not 40 milligrams? So we're going to start with our hypotheses. So our null hypothesis is that the mean is 40, and the alternative, because you believe it's not, is does not equal 40. We go through our checklist to make sure that we can run a hypothesis test. It is random. It is independent, and we have a sample size of 30, which means it is normal. So we can go ahead and perform our test. So our sample mean is 39.2, mu naught is the 40, sample standard deviation 7.5, n is 30, and alpha equals 0.02. Our next step is to calculate the t-value. So take our mean, 39.2, minus 40, over the sample standard deviation, 7.5, over the square root of n, which is 30. Remember, any formula that we use in Chapter 9 will be given to you for the quiz, so you don't have to memorize these. So when we plug in our formula into our calculator, we get negative 0.58. So we're going to draw our curve. We are going to need two critical regions because our alternative hypothesis is does not equal, which means we have to split up alpha within these two regions. So half of 0.02 is 0.01. So to find our two critical values, we go to our upper tail probability of 0.01, and then our degrees of freedom are 29, which 29 is in our table. That gives us 2.462. So we have a t-value that's negative, so it's not going to be in our upper region. So is negative 0.58 less than negative 2.462? And it's not, which means we fail to reject the null hypothesis. So what this means is there is no evidence to show the mean level of caffeine is not 40 milligrams. So remember, it is important to remember your units when you're writing your conclusion for a significance test involving a mean. Our next example is you are employed by an environmental conservation agency that recently claimed more than 30% of U.S. consumers have stopped buying a certain product because the manufacturing of the product pollutes the environment. You want to test this claim. To do so, you randomly select 1,050 U.S. consumers and find that 32% of them have stopped buying this product because of pollution concerns. At alpha equals 0.10, can you support the claim? So our null hypothesis is going to be that the proportion equals 0.30. The alternative hypothesis is going to be greater than 0.30 because it does say more than 30%. So our alternative, where we're testing that, it is actually greater than 0.30. So we do have, it does meet our criteria for random and independent. And then just to check that it's normal, for a proportion, we have to do n times p, so 1050 times 0.30, which is 315, which is greater than or equal to 10. And then we do 1050 times 1 minus p, which is going to be 0.70, and we get 735, which is also greater than or equal to 10. So it is normal. So our p hat is going to be the 0.32, p naught is 0.30, n is 1050, and we have alpha is 0.10. So we're going to calculate our z-score. Do 0.32 minus 0.30 divided by the square root of 0.3 times 0.7 all over n, which is 1050. So we're going to plug this into our calculator. And we're going to get 1.41. Next, we need to calculate our p-value. So I'm going to actually perform the traditional significance testing method. It is the method I prefer. You can perform our other significance test that involves calculating a p-value with our z-score table, but I prefer just using one table. So our z critical value at alpha at 0.10 gives us a critical value of 1.282. So we need to check to see if our test statistic is in that region. So 1.41 is greater than 1.282, which means it is in our critical region, which means we reject our null hypothesis. Even if you were to use our other testing method, you should still find that you reject the null hypothesis, which means there is evidence to show the proportion of people who stopped using the product is greater than 30%. Next, we have that a zookeeper claims that the weight of a polar bear egg is 600 pounds. You think the zookeeper is nuts and set off to disprove their claim that it is much less. You gather a random sample of 200 polar bear eggs and find they have a mean weight of 567 pounds with a standard deviation of 15.7 pounds. Is there enough evidence that alpha equals 0.01 to reject the zookeeper's claim? I am aware that polar bears do not lay eggs, but we're going to go with it. So our null hypothesis is going to be that the mean equals 600. The alternative is going to be that the mean is less than 600. We do have random. We are independent. We have a sample of 200, which is greater than or equal to 30, so it is also normal. So our sample mean is 567. Sample standard deviation is 15.7. N is 200. And alpha is 0.01. So when we calculate our statistic, we're going to do 567 minus 600 divided by 15.7 divided by the square root of 200. Which is going to give us negative 29.73. So our test statistic is going to be negative because we're talking about less than. So alpha 0.01, and then our degrees of freedom are 199, so we're just going to use 100 because that's the closest value in our table. We have negative 2.364. And obviously negative 29.73 is less than that, which means we are going to reject our null hypothesis, which means there is evidence to show that the average weight of polar bear eggs is less than 600 pounds, assuming that polar bears did lay eggs, which they don't. The State Fish and Game Division claims that 75% of the fish in Homestead Creek are rainbow trout. However, the local fishing club caught and released 200 fish one weekend. They found that 170 were rainbow trout. Does this indicate that the percentage of rainbow trout in Homestead Creek is more than 75%? Starting with our hypotheses, the null hypothesis is that the proportion equals 0.75. The alternative is going to be that the proportion is greater than 0.75. We do meet the conditions of it being random and independent. And then 170 times 0.75, 200 times 0.75 is 150, which is greater than or equal to 10. And then 200 times 0.25 is 50, which is also greater than or equal to 10. So it is also normal. So our sample proportion is going to be 170 out of 200, which is 0.85. P naught is the 0.75. N is 200, and because we're not given a specific alpha, we use 0.05. So our test statistic Z, we're going to do 0.85 minus 0.75 all over 0.75 times 0.25 over 200. We're going to get 3.27. Anytime we have a test statistic that does not fall within our Z-score table, I would definitely use the traditional significance testing method. Just because that way we're comparing it to a Z-score instead, a Z-critical value instead of the table where we're not, where we don't have one specifically. So our Z-critical value, we're going to find alpha 0.05 and gives us a Z-critical value of 1.645. 3.27, so talking about 0.05. 3.27 is greater than that, which means we are going to reject the null hypothesis, which means there is evidence to show that the proportion of trout, rainbow trout, in Homestead Creek is greater than 75%. Last problem says a new bus route has been established between downtown Denver and Inglewood, a suburb of Denver. Dan has taken the bus to work for many years. For the old bus route, he knows from long experience that the mean waiting time between buses at his stop was 18.3 minutes. However, a random sample of 13 waiting times between buses using the new route had a mean of 15.1 minutes with a sample standard deviation of 6.2 minutes. Does this indicate that the population mean waiting time for the new route is less than what it used to be? So the null hypothesis is that the mean is 18.3. The alternative is that it is now less than 18.3. So we do have random and independence, and our sample size is 30, which is greater than or equal to 30, so we can perform our significance test. So our sample mean is 15.1, mu naught is 18.3, sample standard deviation is 6.2, n is 30, and alpha is 0.05. Calculating our t-value, we're going to do 15.1 minus 18.3 over 6.2 divided by the square root of 30. And we're going to get negative 2.83. So we're going to have a negative critical value because the alternative hypothesis is less than. So using our upper tail probability of 0.05 and degrees of freedom of 29, we're going to have negative 1.699. So is negative 2.83 less than negative 1.699? And it is, which means we reject the null hypothesis, which means there is evidence to show that the average wait time between bus stops is less than 18.3 minutes. Let me know if you have any questions about performing significance tests for proportions or means before you take the quiz.